Question 3. From a normal population with unknown population standard deviation, a sample size 40 is taken, and the sample mean is 52, and the sample standard deviation is 8. Now we do not know the population standard deviation, but the sample size is large enough, so we can still use z-score, but we'll have to use sample standard deviation to calculate an estimated standard error. So we use this formula. Okay. So when you in your assignment, you need to make sure that you write down the correct formula. Then we plug in the number. Since we use z-score, so the z-score corresponding to 90% confidence interval is still 1.64. But now the standard error changed. Is 8 divided by the square root of 40. Okay. Then we complete these two calculations and obtain 49.93 as a lower bound and 54.07 as upper bound. Then we proceed to build a 95% confidence interval. Again, the only thing that actually changed is the standard error here. We complete two separate calculations and obtain the lower bounds 49.52 and 54.48. Okay. 3C, explain why the interval width differ between 1A and 3A and between 1B and 3B. So in this graph, I actually put in the intervals from 1A, 2A, 3A, and 1B, 2A, and 3B is all here to make the comparison very clear. 1A, we use here 90% confidence interval. 2A is 90% confidence interval. 3A is also 90% confidence interval. But for 3 questions, the sample size increases from 10 to 25 to 40. As a result, the interval width decreases. That makes the estimation become increasingly more accurate. The sample size makes the big difference. The sample size makes the big difference. So when the sample size increases, the estimation, the intervals become narrow for the same level of confidence. So that is what causes the interval width differ among these 3 questions. Same can be said about those intervals for 95% confidence level. 4. From a normal population with unknown population standard deviation, a sample size 25 is taken, and the sample mean is 52, and the sample standard deviation is 8. Clearly, this is a case where we do not know the population standard deviation, and the sample size is smaller than 30. So this is a case where we had to use t-score. Okay. For A, build a 90% confidence interval for the population mean. We use this formula. That involved t-scores and an estimated standard error. Now we begin to bring in the actual value. The sample mean 52 plus and minus. This is the t-score that corresponds to 90% confidence interval. Now let's go to a t-table to see how we obtain this t-score 1.71. Now for t-score, to obtain a t-score, we not only need to know this probability, 90%, but also we need to know the degrees of freedom. The degree of freedom is the number of cases minus 1. The sample size in this question is 25. So 25 minus 1 is 24. So 90% and degrees of freedom 24. Let's go to a t table. Here is the t table. On this t table, there are two lines here. For now, focus on the second line, the level of significance for two-tailed test. For two tails, ignore for the one-tailed. Now focus on level of significance for two-tailed test. What is the level of significance? Now we said that for 90% confidence interval, that the 90% is the opposite of the level of significance. In other words, if we have the level of confidence 90%, therefore the level of significance would be 10%. 100% minus the level of confidence give us the level of significance. So if the level of confidence is 90%, therefore the level of significance will be 100 minus 90, that is 10%. So for 10% level of significance, that corresponds to a 90% confidence interval. So we look for this column, the column with the heading 10%. Now the degrees of freedom, read from the first column. You go down until you find 24. 24, then you read across until you find the column with the heading 10% here. Okay. The t-score 1.71. 1.71. That is 1.71. So 1.71, this t-score corresponds to 90% confidence interval with degrees of freedom 24. Sample size 25 minus 1. So we have a t-score of 1.71 multiplied by the standard error 8 divided by the square root of 25. Then you complete these two separate calculations for lower bound and upper bound, and that is 90% confidence interval built with t-scores. Built with the t-scores. Now we can proceed to build a 95% confidence interval for the population mean. Same formula, but now we have t-scores that correspond to 95% confidence interval, and the degrees of freedom is still 24. Let's go to this table here, t table. 95% confidence interval correspond to the level of significance 5%. You read down from this column until you hit degrees of freedom 24. You have a t-score 2.06. 2.06 right here. Okay. 2.06 multiplied by standard error. Complete these separate calculations and obtain the lower bound and upper bound. Now, 4C. Explain why the interval width differ between 2A and 4A and between 2B and 4B. Let's first focus on the comparison between 2A and 4A. In both questions, we have a 90% confidence interval. In both questions, we use sample size 25, but for question 2A, we use z-score For question 4a, we use t-score. The result is that the interval have different width. The interval we build with the z-score is narrower than the interval we build with t-score. Why is that? Why is that? Explain why. Why this difference in interval width occur? This is because of the characteristics of normal distribution and t-distribution. Let's go to this chart again. Normal distribution is more concentrated than student t distribution, and the student t distribution is more spread out than the normal distribution, especially when the sample size is small. Now we have a small sample size. The sample size is 25. Therefore, the difference between z-score and t-score is significant, and that is what cause the interval size built with z-score narrow than that of than the interval size built with t-score. So that explains that. That also help increase the accuracy of estimation. For the same reason, you can also explain the difference between 2b and 4b that correspond to 95% confidence interval. Okay. Question number 5. From a normal population with unknown population standard deviation, a sample size 10 is taken, and the sample mean is 52, and the sample standard deviation is 8. Again, we have a situation where we do not know the population standard deviation, and the sample size is smaller than 30. So this is another case where we have to use t-score in building the confidence interval. 5a, build a 90% confidence interval for the population mean. We use this formula, plug in the numbers. Here the t-score that correspond to 90% confidence interval is 1.83. Let's go to t-table to find how we determine this t-score. Remember, the sample size is 10. That tells us the degrees of freedom is 9. Okay, go to the t-table. It's 10% level of significance. Later on, we explain what is the level of significance. But now, let's just use this terminology. 10% goes down to the degrees freedom and 10 minus 1. So the t-score is 1.83. 1.83. Come back here. 1.83 multiplied by standard error, which is 8 divided by the square root of size 10. Two separate calculations for lower bound and upper bound. We have this interval. Then we proceed to build 95% confidence interval. Same formula, but now t-score that correspond to 95% confidence interval is 2.26. Let's go to the t-table to find that value. 5% level of significance that correspond to 95% confidence interval. Degrees freedom is 9, so 2.26. 2.26. So then you calculate the lower bound and upper bound separately, and you obtain the interval. 5c, explain why the interval width in this question differ from those in question number 1 and those in question number 4 for the same level of confidence. Let's first look at the comparison between question number 5 and question number 1. 1A versus 5A. Both are 90% confidence interval. Both are sample size 10. Sample size are the same. But one use z-score, one use t-score, and therefore the one that use z-scores give a narrow interval for the same level of confidence. So in terms of why the difference? Because we use a z-score for question 1, use a t-score for question 5, and that's why. Same for 95% confidence interval, same sample size, but a different score. Z-score versus the t-score. Therefore, the one that built with z-score has narrow interval than the one built with t-score. Now let's look at the comparison between question number 5 and question number 4. Question number 4, 90% confidence interval, use t-score. Question number 5, 90% confidence interval using t-score, but different sample sizes. Question number 4, use sample size 25, not larger. That results in a narrow interval size, more accurate estimation than the question number 5A, which use a smaller sample size and they give you a wider interval, less accurate estimation. And same can be said about the 95% confidence interval. Okay, when you use larger sample size, give you a more accurate information than when you use a smaller sample size.